Python is an amazing programming language where we can get plenty of tools for multiple different purposes. In our previous video, you must have seen how much we were able to solve multiple tasks, simple to complicated, by making use of Python functions. But now in this video, we are going to explore a niche category of functions in Python, which are known as anonymous functions. So before we begin, just make sure that you guys have subscribed to our channel and hit the bell icon to stay updated with all the latest videos coming from Dataisgood YouTube channel. Now time to get started. Here is the agenda for this Lambda Functions in Python course. We will first begin with understanding what the Lambda functions are, their advantages, and why they are known as anonymous functions in Python. After that, we'll be seeing how to write Lambda functions along with some predefined functions such as filter, reduce, man, and apply. Finally, we will be using these Lambda functions to solve some algebraic expressions. We will also have a couple of assignments for you so that you can also practice Lambda functions and expressions on your own. Our goal for this video is to bring your proficiency in Python Lambda functions and expressions. After finishing this video, you will get an amazing confidence when it comes to using Lambda functions. In fact, when you come across any problems, implement these functions. Alright, so without any further delay, let's start this session with our first agenda, and that is understanding the Lambda functions and knowing why it is also known as anonymous function. An anonymous function is a function that is defined without a name, while normal functions are defined using the def keyword in Python. Anonymous functions are defined using the lambda keyword. Hence, anonymous functions are also called lambda functions. The main purpose of anonymous functions comes into picture when we need some function which is going to be used only once or only for a certain number of time. The anonymous functions are also helpful when we have to solve simple tasks. We can say that these anonymous functions help us to define smaller functions without a name. Time to dive into the code. For that, I'm going to open a Jupyter Notebook. We will be using Jupyter Notebook. The Jupyter Notebook is an incredibly powerful tool for interactively developing and presenting data science projects. But if you're using any other code editor like Sublime, Atom, or Visual Code, you can use that as well. I prefer Jupyter Notebooks. The first thing we are going to do is to rename this Jupyter Notebook to Python Lambda Functions. Now we are ready to create our first Lambda functions in Jupyter Notebook. But before that, we should learn about the syntax of the Lambda function. Lambda functions are created using the lambda operator. The first thing that we will need to specify is the lambda keyword, and then following that, we will have to specify the arguments or the inputs. Do notice the colon symbol, because after the colon symbol, we will be specifying the expression that needs to be solved. This is the syntax of lambda functions. Let's take an example. We are going to take a variable named a and then specify the lambda keyword and then colon. After the colon, we will specify the expression that we would want should be executed by the lambda function. We have a simple expression, which means that if we call this function, it will simply add 10 to the input value. Let's first call this function with input as 10. Now let's execute this function. We will press Shift and Enter every time we want to run or execute a cell in a Jupyter notebook, we will press Shift and Enter at the same time. Now we can see that we have got the output, which is 20, which means the 10 got added to 10. All right, we'll try one more time. But this time we pass our input as 358. Now after running this cell, you can see that the output comes out as 368, which means that the value of 10 got added to the input. Now let's try to define one more lambda function like this. But this time we'll have a different expression. This time let's take a variable named as b and then specify the lambda keyword with a colon and then the expression. This time our expression is a square. Now let's do the testing and check if this works. We will call our function with an input of 4. You can see that when we execute this cell by pressing Shift and Enter, the output comes out to be 16, which is exactly what we have expected because 16 is the square of 4. Now this feels so good when your code works fine. And that's why I'm going to check this function one more time with an input of 7. This time again, we got the correct value as the output, which is 49. Till now, we have defined very simple lambda functions with only one argument. But lambda functions can take any number of arguments, which means that we can solve more complicated problems using the lambda functions. Let's try one such example. This time, we are going to take a variable named c and then we will specify the lambda keyword and colon. And finally, we'll specify the expression which we want to execute. Since we have 2 arguments, hence we will specify 2 arguments which are x and y. We will specify our expressions as x star y to get the multiplication of the 2 arguments. Now let's call this anonymous function by specifying 2 arguments. Our first argument can be 20 and our second argument will be 60. So let's execute this cell by pressing Shift and Enter. We got the correct answer as the output is 1200. But what will happen if we only pass one argument for this lambda expression? Let's see by doing it. Now I'm going to call this lambda expression with only an argument, that is 20. You can see that when we run the cell, we get an error saying that one of the arguments is missing. Everything we did till now by using the lambda expressions can also be done by using normal functions as well. Let's just take a look how we can do the same exact thing by using the normal functions in Python. First of all, we will have to define the def keyword and then we will have to specify some name for this function. Let's say the name for this function will be mul. Now after defining the name, we will specify the parenthesis inside which we have to specify all the arguments that we are going to use for this function. As we know that we are going to use 2 arguments, so we'll specify x and y inside this parenthesis. After the arguments are specified, we'll put a colon and then go inside the function. Now inside this function, we can write our expressions. This time, our expression is very simple, which is to multiply x and y. We have defined a function which can take in 2 numbers and return the multiplication value of these 2 numbers. Now let's call this function with 2 arguments that are 20 and 60 and check the output by pressing Shift and Enter, we can see that the output is the same as before, which means that we can use these normal functions as well for executing such small expressions. Generally, when we have many small functions to execute, it can be a bit inconvenient to keep on defining functions, which are mostly single use. In these cases, Lambda expressions are more effective for execution of smaller programs. Time to move on to the next agenda of this session, that is to use Lambda functions inside filter, map, and reduce functions. We will start with a filter function. The filter function offers an elegant way to filter out all the elements of a list, for which the function returns true. The filter function in Python takes in a function and a list as an argument. The function that filter function takes in can be a Lambda expression. Now let's go back to the Jupyter notebook and use the Lambda expressions within the filter method. I will just add a new heading here. Before defining a filter method with Lambda expressions, it is crucial for us to know about the syntax of the filter method. You can see that the filter method takes in two compulsory arguments, where the first argument will be the Lambda expression, and the second argument will be the iterables, where the iterables can be any set of data points such as a list or a set, etc. So let's define a list in a variable named as x. I'm going to add 5, 6, 7, 8, 9 and 2 elements in this list. Now that we have defined our list, in the next step, we will be creating the filter method. This will filter out all the ODD elements from the list and return only the even elements present inside the list. So let's get started. We will take a new variable to store the filter method. Inside the filter method, we will define the Lambda expression to eliminate all the odd elements from the list. The expression will be a%2 is equal to 0. It's going to return elements from the list which, when divided by 2, leave 0 remainder. The second argument will be the iterable. For this case, we have already defined a list stored in a variable called x. Hence, our second argument will be x. Let's execute this cell. Shift plus Enter. The output says filter object along with some ID. Some of you might be expecting a different result. Maybe you might have been expecting a list output with all the even elements present inside the list. The ID we've got is the object reference. Filter map functions always return an object which is iterable. This is because we often want to do the filtering in a lazy sense. We don't need to consume all of the memory to create a list up front. Think big sets, big sets. The iterable object can be passed to a simple Python function as a list to actually execute it. To get the expected output, we will just have to put the filter method inside a list function. Now let's execute this cell one more time. This time you can see that the output returns a list containing all the even elements present inside the list, that is 6, 8 and 2. Next method on the agenda is the reduce method. The reduce function takes a function and an iterable and returns a single value. Reduce function performs a repetitive operation on the iterable pass. Now let's go back to the Jupyter notebook and try to understand the reduce method by taking some examples. Another important thing to remember while using reduce function is that the reduce function is in the module funct tools, which contains higher order functions. Higher order functions are functions that act on or return other functions. Therefore, in order to use the reduce function, we need to import the functools module. So let's do that. After importing the functool library, we will specify a list in a variable named as A. In this list, we are specifying a total of 6 elements, which are 4, 8, 2, 9, 7, and 1. Now we are ready to define the reduce method. The syntax for the reduce method is exactly the same as that of the filter method, which means that the reduce method will also take in 2 arguments, where the first argument will be the expression or function, and the second argument will be the iterator or sequence of data points. Let's create a reduce function. It will return us the sum of all elements present inside a list. We will take a variable named as func, and then we will call the reduce function from the functools library. After that, specify the lambda expression with 2 arguments, x and y, and then put a colon and specify the expression. Since we want the total sum of all the elements present in the list, so we will put our expressions as x plus y. This will return us the total sum of the list. Let's execute this cell by pressing Shift and Enter. We can see that the output is 31, which is the total sum of 4, 8, 2, 9, 7, and 1. As discussed, reduce function will return a single value only. Alright, time to move on to our third function, map function. The map function returns a map object after applying the given function to each and every item or element of a given iterable. Now let's come back to the Jupyter notebook and find out how we can use the lambda expression within the map function. Now let's check the syntax for the map function. We can already see that the syntax for the map function is the same as the filter and reduce function, which means that the map function takes in 2 arguments, where the first argument is the lambda expression and the second expression is the iterable. Now let's create a list stored in a variable called A. In this list, we have 5 elements, which are 7, 5, 9, 2, and 6. The next step for us is to create a variable called func, which will store our map function. Then we will define a map function, and inside that map function, we will specify our lambda expression. We have already learned that using the map function, we can apply an expression to all the elements of the iterable. Hence, let's make an expression which can add a value of 10 to all the elements present inside the list. Now let's try to print the output using the print function. We can see that this time also we're not getting any output. The output is a map object with same ID. Let's try again. This time we'll put the map function inside a list function so that we can get the expected output. Now let's execute this cell by pressing Shift and Enter. We can see that we got the correct output. All the elements of the list are added with 10. We implemented the lambda expressions with the filter, reduce, and map functions. But now it's time for us to learn how to use the lambda expressions with the apply functions. Talking about the apply function works exactly the same as that of the map function. But then, what is the difference between these 2 functions, apply and map? there is a very basic difference between map and apply function, and that is a map function can only be used along with the series data, whereas the apply function can be used with both the series and the data frames. Now, as we have already known about the map and apply functions, let's implement them on a data frame in a Jupyter notebook. Now, coming back to the Jupyter notebook, we will import the Pandas library. Here we are importing the Pandas library because the Pandas library will help us to read the data frame inside the Jupyter notebook. After the Pandas library is imported, we are ready to read the data frame. For the demonstration of the apply functions, we are going to use the very famous IBM employee dataset. This dataset contains all the details of the employees in the organization, such as the age of the employee, the salary, the department, the education, the ratings, the satisfaction, and so many other things. Now, let's read this dataset. We are going to read this dataset by using the read CSV function. Pandas provides us this function, which can read any type of CSV file in a Jupyter notebook. Here, CSV refers to comma-separated values. Inside the read CSV function, we will specify the address of the data frame and save it on to a variable named as data. We are saving our data frame in a new variable so that we can access our data frame anytime throughout this Jupyter notebook. And finally, we call the head function over the data so that we can get to see the top 5 rows of this data frame. This head function helps us to get the top 5 rows of any data frame. We can see that this data frame has so many columns, such as age, attrition, business travel, daily rate, department, etc. Now, if we look at the daily rate column, we can very easily realize that the values present in the daily rate column are in dollars. Now, all we have to do in this scenario is to convert the value of daily rate column from dollar to rupees using the map or apply function. So, let's get started. First, we'll try to do this task by using the map function. For that, we just need to call the daily rate column from the data frame. And after that, we'll specify the map function so that we can define our lambda expression inside the map function. So let's define the expression. We have to convert the values of the daily rate column from dollar into rupees, for which we will have to multiply all the values of the daily rate column with 75. Let's do that and execute the cell by pressing Shift and Enter. All right, we can see the change in the values of the daily rate column before and after. You can notice that before the value of the daily rate columns were like 1102, 279, 1373, and so on. But after the map operation, the values are like 82,650, 20,925, 1,02,975, and so on. We can see that the values have been changed. Now let's try doing the same using the apply function. The steps would be exactly the same. So I'm going to copy the code from the upper cell and only replace the map function to apply function. After executing the cell, we can see that it is also working fine and giving us the exact same result as a map function. So the question is, how are these map and apply functions different? Although we have discussed the answer, let me just repeat the answer so that we can recall the fact. The map function can be used only for series data, whereas the apply function can be applied to not only series but also the data frames. Let's demonstrate this fact by taking one more example. Coming back to the head of the data frame, you can see that we are not only having the daily rate column, but we also have hourly rate and monthly rate columns, where we would like to do the same change. These three columns are in dollars, and we need to convert them into rupees. So let's try doing the same by using the map function first. Here, I'm going to select all the three columns, daily rate, hourly rate, and the monthly rate at the same time by using double square brackets. After that, we will specify the map function, and then we'll also specify the exact same lambda expression to convert the dollars into rupees and execute this cell by pressing Shift and Enter. You can see that when we execute this cell, we get an attribute error. This attribute error tells us that data frame object does not support the map function, which means that if we want to perform these kind of operations where data frame object is associated, we will have to use the apply function. So once again, copy the above code and just change the map function with the apply function and execute the cell. Now this time you can see that the cell got executed successfully and we got the right output which we were expecting. We can also notice the changes in the three columns, daily rate, hourly rate, and the monthly rate. Finally, we learned the difference between the map and apply functions and also got to understand it through some very simple examples. So I hope you guys are clear on Lambda functions in Python. If you guys have any doubts in Lambda function, then please do let us know in the comment section and our Dataisgood team will be ready to help you. With this, we've reached the end of this video. I hope you all enjoyed learning about Lambda functions in Python and also got to learn something new. In case you have any suggestions for us, then please let us know about that in the comment section and we'll try our best to revert to you and implement your suggestions at the earliest possible. Bye, and don't forget to subscribe our YouTube channel if you haven't subscribed it yet. See you.